Welcome to my channel. In this video, you're going to learn about the circle and its chord and center relationships. Now let's learn about the chord and center relationships of a circle. So I have here circle O. This is the center and that's the chord of the circle. And then if we're going to draw a line there from the center, this line from the center to the chord form a right angle, or this one is perpendicular to the chord. This line segment from the center. Okay, aside from being perpendicular, that segment also divides the chord into two congruent segments. Okay, it means that the length here is equal to the length there. Now, that segment, the segment from the center of a circle is perpendicular bisector of a chord of the circle. Perpendicular bisector form 90 degrees angle. At the same time, it divides the chord into two congruent segments. Now, another one. That's chord AB or segment AB, and another chord CD, segment CD. It says that if two chords are equidistant from the center of the circle, then the two chords are of the same length. It means that this is the center. If the length here going to the chord is equal to the length of from here going to this another chord, it means that the two chords are also of the same length. So let's say that is 2 units, another one is 2 units. So therefore we can say that segment AB is congruent to segment CD. Now, let's apply the chord and center relationships of a circle. So we're asked to find the length of chord AB or segment AB. So segment AB is there. So that's the chord. And the distance from the center of this chord is 3 centimeters. Okay, now we know also that this segment is perpendicular to the chord. And at the same time, it divides the chord into two congruent segments. Now, if we're going to draw a line from the center to one of the endpoint of the chord, that is now what we call the radius of the circle. And we can also do that on the other side. So that's another radius of the circle. Okay, now, if the radius of the circle is 5 centimeters, we can now solve the side of the right triangle using Pythagorean theorem, which is c squared is equal to a squared plus b squared. To solve for c is equal to the square root of a squared plus b squared. To solve for b, square root of c squared minus a squared. And to solve for a, that is equal to the square root of c squared minus b squared. Now, let's say the missing side here is a. So this is b. Now, b is equal to 3. And we have the c, which is the hypotenuse of the triangle. The radius of the circle is the hypotenuse of the right triangle, and that is equal to 5. So we are looking now for the value of, or we're going to find the value of a. It means we're going to use this formula. Okay, so that is now a is equal to c is equal to 5, so square that, and then minus 3 squared. Okay, so 5 squared means 5 times 5, and that is equal to 25, and 3 squared means 9. So 25 minus 9 is equal to 16. And what is the square root of 16? That is 4. It means that the value of a here is equal to 4. So this is 4 centimeters. And this is also 4 centimeters here. Therefore, what is now the length of the chord? Segment AB now is equal to 8 centimeters. The length of the chord. Let's have another example. How far is the chord from the center of a circle if its radius is 10 centimeters and the chord is 12 centimeters? So this time, the unknown is the length from the center to the chord. So let's draw a line there. And now given is the radius, so we can have the radius here and the length of the chord. So let's have the radius is equal to 10 and the chord is 12 centimeters. So that's 10 centimeters. Okay, so what is missing now? Okay, if the chord is 12 centimeters, it means that this side measures 6 centimeters only. Because this is only half of the chord. Now, this is missing and we can use the formula here. So what we have now is B is equal to the square root of C squared minus A squared. And that is now equal to, B is equal to C squared, that is the hypotenuse. And that is equal to 10. So 10 squared, and that is minus 6 squared. 10 squared means 10 times 10. 6 squared means 6 times 6. So that is 100 minus 36. And that is equal to 64. What is square root of 64? That is equal to 8. It means that the distance of the chord from the center is 8 centimeters. So this is 8 centimeters here. Let's have another one. Find the radius of the circle if the chord is 24 units and its distance from the circle is 5 units. So given now the chord, which is 24 units, and the distance of that chord from the center, that's the line segment there, is 5 units. It means that we are going to find the radius, so we can draw a line there from the center to one end point of the chord, and that's the radius. That is missing. And if the chord is 24 centimeters, or 24 units, sorry, this is 12. Because that is only half of the chord. This is the whole chord here. And this is only half. So now we have, again, a right triangle, wherein the missing side here of the right triangle is the hypotenuse. So we can use C is equal to the square root of A squared plus B squared. So let's do that one. C is equal to 12 squared plus 5 squared. And that is 12 squared is 144 and 5 squared is 25. Means 5 times 5, 12 times 12. 144 plus 25 is equal to 169. And the square root of 169 is 13 units. Okay, so the length here is 13. Means that the radius now of the circle is 13 units. So this is 13. Okay, so that's how you're going to find the length of the chord, the distance from the center, and the radius of the circle by using the relationship of chord and center. That's all for this video, and thank you for watching. Please don't forget to subscribe to my channel. See you in the next one. Bye!